Hello, this is part A of the Chapter 8 lesson. This chapter is titled Power and Sample Size Determination. There are a lot of concepts and definitions and ideas in this chapter, and some of them are rather complex. In this lesson, we're going to try to simplify things down as much as we can and focus on the most important ideas. In part A, we're going to talk about confidence intervals, and then subsequent parts we're going to talk about hypothesis testing. And so one note here for this lesson, we're going to be using the Excel workbook chapter 8. So sample size. The first step in any statistical study, regardless of what type of study it is to determine the necessary sample size. We need to figure out just how many people do we need to survey. Is 15 enough? Do I need 50? Do I need 500? Do I need 5,000? Just what it is, just what do I need? Well, there's many factors to consider. There's financial. If we don't have a lot of money to spend, then we're not going to be able to have a very large sample size probably. Logistical, just how possible is it to get the data that I need? How much work is it going to be? Statistical. What does our statistics say about what our sample size is? And then another idea is attrition. A study could take the length of many years, and you may have some people who start the study but who can't finish it for whatever reason, and so you've got to take that into account. Now, in this lesson, we're going to focus on mainly statistical ideas and statistical considerations, and we'll briefly take into account attrition. Financial and logistic issues, those are beyond the scope of this class. So far we've talked about basically two ways of analyzing data. We have confidence intervals and then hypothesis testing. To do a confidence interval, we start off by choosing a confidence level, which is typically 95%, and then we go out and we collect our data and we calculate a margin of error, and then we use that margin of error to get a range of possible values for the parameter. What we're going to talk about here in this lesson is what does the confidence level mean? What does that number 95% mean? And then we're going to talk about what affects the margin of error. How does the confidence level affect the margin of error, and what else affects it? And then what does the size of that margin of error tell me about the range of possible values and how that range is important. The second way of analyzing data is hypothesis testing. In hypothesis testing, we start off by selecting a significance level alpha, which was typically 0.05, and then we compared our p-value to that. And then related to this significance level is an idea called power, which the book has talked about, but we haven't really mentioned it in any of our lessons. Here in this chapter, we're going to talk about what does that significance level mean in hypothesis testing, and what is power, why is that important, what does it mean, and what type of things affect the power, and how that can help determine our sample size. So let's start off by looking at example 6.1 from the book. Now this is obviously from chapter 6, but we're going to use this to illustrate some ideas. Suppose that we want to know the mean systolic blood pressure of all people, and let's call that number mu. Well, in order to find the exact value of mu, I'd have to go out and get information from every single person in the United States, I guess. Take their blood pressures, add them up, divide by the number of people, and that would give me the exact value of mu. Well, that's obviously impossible to do. So we go out and we get a sample of 3,539 people. We take the blood pressure of each. We calculate a mean blood pressure of 127.3 and get a standard deviation of 19. And so let's use this information to calculate a 95% confidence interval estimate of mu. And now this is what we did in chapter 6 when we talked about confidence intervals. And so to perform this calculation, we could use the workbook chapter 6, but I've actually put this worksheet in the workbook chapter 8. So if you go to that workbook and the worksheet mean, we can enter our necessary information here, our 95% confidence level, our sample size, sample mean, sample standard deviation, And and then it calculates the margin of error and gives us this confidence interval estimate. So we would interpret this interval by saying that we're 95% confident that mu is somewhere in between these two numbers, 126.6 and 127.9. Okay. Now let's look at changing some things here. And so we're going to look at first changing the confidence level. How does the confidence level affect the margin of error and our confidence interval? So here at the first is our original calculations with a 95% confidence level. Here's our margin of error, and here's our confidence interval. Now let's suppose that we try to use an 80% confidence level. And our summary statistics here don't change at all. We just have an 80% confidence level. Now look at what that does to the margin of error. It went from 0.6 down to 0.4. So we have a smaller margin of error. Now look at what that does to the confidence interval. The lower limit went from 126.6 up to 126.9 almost. So the lower limit got bigger. Look at what happens to the upper limit. It went from 127.9 down to 127.7. So the upper limit got smaller. So that means that our lower limit and upper limit got closer together. So that gives us a narrower range of values for our possible values of mu. So we would interpret this by saying that we're 80% confident that mu is somewhere between 126.9 and 127.7. So, smaller confidence level gives us a smaller margin of error and a narrower confidence interval. Now, let's increase our confidence level. Let's suppose we choose to use a 99% confidence level. Look what that does to the margin of error. It went from originally 0.6 up to 0.8, so we have a much bigger margin of error, and that's going to give us a wider confidence interval. Now let's choose an even higher confidence level, 0.9999, so we're at a 99.99% significance level, or confidence level. And look what that does to the margin of error. It went up to 1.2, and we have now a much wider confidence interval. And so what this illustrates is that if we choose a higher confidence level, then we have a larger margin of error and a wider confidence interval. Now, this is both good and bad. It's good in the sense that we're more confident that mu is in the interval than if we worked at a lower confidence level. But it's bad in the sense that we have a wider range of values for mu, means that we have a less precise estimate of mu. And so a wider range of values doesn't really give us as much information about mu. We could, for instance, give a confidence interval by saying, well, we think that mu is somewhere between 0 and infinity. Well, that would be a 100% confidence interval because we'd be 100% confident that mu is somewhere between 0 and infinity. But that confidence interval is completely useless. It gives us no information about what mu is. So a wide confidence interval is bad in the sense that it gives us a less precise estimate of mu. So our goal is that we would like a high confidence level so that we're really confident that mu is in the interval, but we'd also want a small margin of error. So a high confidence level and a small margin of error. That's ideally what we want. Okay. Well, let's look at changing now, for instance, the standard deviation of the sample and look at how that affects the margin of error. So here's our original calculations where we had a standard deviation of 19 and a margin of error of 0.6. Now, in our next calculations, let's decrease the standard deviation to 10 and look at what that does to the margin of error. That decreases it down to 0.3. So smaller standard deviation gives us a smaller margin of error. Let's decrease the standard deviation even more, down to 5, and that gives us a smaller margin of error still. So now let's increase the margin of error, or the standard deviation, to 40, and look at what that does to the margin of error. We get 1.3, which is over twice as big as the original. And so what this illustrates is that if we have a larger standard deviation, we get a larger margin of error, which is going to correspond to a wider confidence interval, which means a less precise estimate. If we have a smaller standard deviation, we have a smaller margin of error, a narrower confidence interval, which means a more precise estimate. So ideally, we'd want a set of data with a small standard deviation so that we get a more precise estimate. Okay. Well, let's look at changing one other thing, the sample size. So atop here are our original calculations with a sample size of 3539, gives us a margin of error of 0.6. Now let's decrease the sample size. So let's suppose that we surveyed only 500 people, but we got the same sample mean and standard deviation. Look what that does to the margin of error. It increases it to 1.6. So smaller sample size gives us a much larger margin of error. Now let's change the sample size to 2,000. So that's between 500 and 3,500. And look what that does to the margin of error. Gives us something in between 0.6 and 1.6. Now let's increase our sample size to 5,000. So that's much bigger than the original sample size. Look at what that does to the margin of error. It decreases it to 0.5. So the point here is that if we have a smaller sample size, we have a larger margin of error, means a wider confidence interval, and a less precise estimate. If we have a large sample size, that gives us a smaller margin of error, a narrower confidence interval, and a more precise estimate. And so we see that the precision of our estimate is affected by a lot of different things. We have the confidence level, we have the sample standard deviation, and we have the sample size. Those things all take into account, or those all affect the margin of error. Well, we can use that information to come up with a formula for calculating the necessary sample size for estimating a population mean. And so if we go back to look at chapter 6, we see that the margin of error for calculating a confidence interval estimate of mu is given by this formula here. The margin of error is this critical value times the standard deviation divided by the square root of the sample size. And so if we so this right here illustrates the points that we've just been making, that the margin of error is affected by the confidence level. Here the critical value corresponds to the confidence level. The margin of error is also affected by the standard deviation and then by the sample size. And so if we just algebraically rewrite this equation, solve it for n, we get this formula right here. So this gives us a formula for calculating the necessary sample size, where again z is our critical value corresponding to the confidence level. Sigma here is an estimate of the population standard deviation, and E is our desired margin of error. So if we know these three numbers here, we can use those to calculate the necessary sample size. Now, one thing that we want to note here is that the population size just doesn't matter. As long as the population size is large relative to the sample size, then the exact value of the population size just doesn't matter. We often think that if we have a larger population, then we need a larger sample size, but this formula here illustrates that that's not the case. As long as the population is large, its exact size just doesn't matter. It could be 5,000, it could be 10,000, it can be 10 million, 10 trillion, it doesn't matter. All that matters are really the confidence level, the standard deviation, and then the desired margin of error. Now, in order to use this formula to calculate the necessary sample size, we need an estimate of sigma, the population standard deviation. And there's at least a couple of ways that we could find this. One way is to use an estimate from a previous survey. Or number two, we could use knowledge of the circumstances. So maybe we just say, well, based off my previous experiences or knowledge of this circumstance, I think that the standard deviation is whatever. And so we can use that as our estimate.